Hi. I know you just pressed play on this episode, but I'm about to ask you to stop listening to me. Yes, this is a strange way to start a new season of our show, I know, but this is my request, or my invitation. If you're so inclined, in just a moment, please press pause and spend 10 or 15 seconds listening to whatever you can hear around you. All the voices, anything making any sort of noise at all. And then press play again. That part's crucial. Please do come back. Okay, are you ready? 3, 2, 1. What did you hear? Could you hear any sounds that weren't made by people?
The doors are closing. Please stand clear of the doors.
If so, consider yourself lucky, because human beings have become very, very loud.
In preparation for takeoff, may I now remind you to fasten your seatbelts.
This relentless noise we make, it's not normal. For most of our time on this planet, we humans have been very good listeners, tuning in carefully to the movements of water, changes in the weather, the voices of other animals. But now, many of us move through our days, or even our entire lives, hearing almost nothing but the sounds of just one species. Our own. If the planet is a dinner party, we're the guests who are ruining the conversation, talking over everyone, assuming that our voices are the most important ones in the room. We're drowning out essential communication between other creatures, forcing them to spend their lives shouting to each other in order to be heard. Or worse, we're silencing them forever. And our noise doesn't only threaten other beings, we're endangering ourselves. And we know things are out of balance. We feel isolated and cut off because we are. With multiple ecological crises mounting around us, many of us feel desperate to help, and there is unquestionably so much work to be done. But maybe the first step is slowing down and letting the voices of our planet mates back in. What if being useful starts with being quiet? What if saving the world begins with listening to it? What changes when we remember to listen to the more than human world? That's the question at the heart of this season of our show. Despite all the damage that's already been done, there is still a vast planetary choir singing around us. It's right there waiting for us, if we turn our attention to it. All over the world, people are hearing those voices and responding. We are in the midst of a listening emergency, but also a listening renaissance. And this season, we'll meet people who are devoting their lives to listening, reconnecting with old traditions or creating new ones, and building tools that might someday allow us to comprehend what other animals are saying in ways we've only dreamed of in the past. It's going to be a fun journey and a fascinating one, but I'm going for something deeper than the wow factor of cool nature sounds. I chose to make this season now because I think all of our ecological crises, climate, extinction, pollution, are essentially breakdowns in relationship. And the first step in healing any broken relationship is listening. So what happens when we do that? Welcome to Threshold. I'm Amy Martin, and this is Season 5, Hark. It's 7 o'clock on a sunny morning, and I'm on a boat heading into Shark Bay, a huge marine reserve off the Western Australian coast. This is Malgana country, one of hundreds of Aboriginal groups in Australia. And in Malgana, the name of this place is Karaguru, which means two waters.
Dolphins straight ahead.
We've barely left the jetty, and Dr. Stephanie King has already spotted a dolphin. It surfaced and disappeared again in a flash, but that was enough time for her to identify it. It was a female named Jindy.
You knew who it was that fast?
Yeah, she does.
Wow.
She's great.
That's Laura Palmer. She's working on her PhD, and the other person with us is research assistant Amelia Clark. All three of these scientists are from the University of Bristol in the UK. Stephanie is the leader of the expedition and the current captain of the boat.
How did you know?
Because of the markings on the dorsal fin. She has an uncle who has a similar fin to her, but you can see the three small nicks, the little rake marks at the top. Each nick is kind of similarly spaced along the fin, almost equidistant from each other. So each dolphin has a unique dorsal fin, we say like a fingerprint, but it's far more obvious than that, I guess like a human face. So they're very distinctive. If you've been working with them a long time, then you recognize all the individuals.
Shark Bay and its surrounding coastal areas are listed as a UN World Heritage Site, and it's easy to see why. The water is a clear turquoise blue, and huge seagrass meadows provide food and shelter for an abundance of wildlife. Sea turtles, dugongs, and more than 300 species of fish, including the namesake sharks. But the superstars here are the dolphins. The scientists of Shark Bay Dolphin Research have been studying them continuously since 1982, making this one of the most carefully observed communities of dolphins on the planet. Stephanie is one of the current co-directors.
Do you know how many dolphins are here, roughly?
2,000 to 3,000. I mean, there's about 1,800 that we have in our catalogue that we work on, and that's just in our core study area in the Eastern Gulf. There's far more than that.
And of those 1,800, how many of them can you identify on site, like you just identified that one in 2 seconds?
I've never tested myself, but maybe we could do that. I know a lot.
Like 200 or like the majority?
Way more than 200.
And when did you first come here?
I first came to Shark Bay in 2014, so 10 years ago now.
And have you been coming almost every year since then?
Every year. I think 2020 was the only year because of COVID, but I come every year, and it's a really important part of my life. Coming here, spending time with the animals, being inspired for the next questions that we want to answer, seeing who's still around, who's had a calf, how are the males doing, who's allying with who. I think this is certainly where I'm at my most happiest as a field biologist. It's where I'd like to be most of the time if I could.
Yeah.
Stephanie studies these dolphins using every non-invasive tool she can find: drone videography, DNA sampling, and especially bioacoustics, recording and analyzing the sounds the dolphins make.
Sound is the primary way that they communicate, and a lot of our research now is starting to uncover exactly what some of these sounds mean and how they're used.
Bioacoustics is the name for a fast-growing field of science, or really an approach to scientific research that's being used across many fields. Sometimes it's also called ecoacoustics or acoustic ecology. All of these labels have slightly different meanings, but they're all based around listening to the more than human world. And they're all booming right now. Over the course of this season, we're going to meet bioacoustics researchers working with all kinds of different creatures, but we're going to dive deep with dolphins. Pun intended. We'll be returning to Shark Bay in several episodes in hopes of really getting to know this team and the way these remarkable animals are using sound. Stephanie says that starts with learning about the dolphins' world overall, their habitats, their relationships, their needs and preferences.
So we look at behavioural complexity in bottlenose dolphins, and that can take the form of foraging specialisations and tool use, which is a great example of animal culture. But we also spend a lot of time looking at cooperation. This is really where my passion lies. Understanding how animals use communication to mediate complex social behaviours like cooperation.
Highly social animals like dolphins, elephants, and people have special needs for communication. We make decisions together, like where to find food or how to respond to a threat. We maintain long-term relationships that we depend on in times of need, and we pass on information to our young. All of this cooperation demands that we develop complex communication skills.
And in Shark Bay, we have male dolphins that form long-term alliances. So these are really significant relationships for these animals. They're investing heavily in these cooperative relationships with each other. And I'm really fascinated by the ways that they do that. So what vocal signals are they using to mediate these relationships? How do they keep track of each other? How do they coordinate their behaviour? So these are all the types of questions that we aim to answer in our work in Shark Bay.
Is the cooperation that they're engaged in, how much of that is happening through sound?
It's mostly happening through sound, and that's because it's a species that lives underwater, right? So vision is restricted because light doesn't travel that far. They have good visual acuity, they've got good vision, but they don't rely on vision because they can't see that far underwater. But sound travels really far.
Dolphins use other forms of communication too, of course.
They can be quite tactile with each other, so they'll spend time petting and rubbing each other, and that's a way of reaffirming or establishing or maintaining relationships.
But Stephanie says sound is central.
They use sound for all important aspects of their life, to navigate their environment, to find food, and importantly, to communicate with each other. So it's their primary modality. It's sound, it's not vision, it's not gestures. And by sharing information through vocal signals, they can let each other know where they are, maybe if they plan to move, if they want to reunite, this type of information.
When I visited the team in May of 2023, they were just getting started for the year. Amelia, who goes by Millie, is a recent master's graduate who's here to get experience as a research assistant. Laura is a PhD student collecting data for her thesis work.
This is my first time in Shark Bay, so I've only been here a week now. We've had lots of amazing days on the water, so certainly very lucky. It was a good time to come.
Laura and Millie are under some pressure because they only have a few weeks with Stephanie. Then she has to leave, and they'll do everything on their own. One of the key things they need to learn is how to take a survey of every dolphin they meet.
By survey, I mean we photograph the group and we stay with them for at least 5 minutes and we write down their predominant behaviour. So are they socialising, travelling, resting? And then we look at who are they with. And by doing that throughout the season over multiple years, and we've been doing it for 40 years now, we have this incredible picture of who associates with who has strong friendships, which dolphins avoid each other, and we can map the social network, if you like, and we can look at the structure and maybe link some of that information to fitness measures, like does being more sociable mean that you're more successful and you have more offspring, for example. You got dolphins, Laura?
No, not yet. They're splashing at basically 0 degrees.
While I've been peppering Stephanie with questions, Laura and Millie are scanning the water for anything that looks remotely dolphinish. Laura said she saw some splashes at 0 degrees, meaning straight ahead, so she moves to the bow of the boat to get a better look.
If we see splashes, we'll check just to make sure it's not dolphins foraging. Anything that looks like it could be a dolphin or indicate dolphin behaviour, we'll check with the binos and maybe even go a bit closer.
I quickly get obsessed with dolphin spotting myself, which was a little dangerous. Stephanie told me that if someone says they see a dolphin and it turns out to be a bird, They have to bake something for the rest of the group back at the research station.
Yeah?
But then Laura calls from the bow. There's definitely dolphin activity up ahead.
We're in business.
The dolphins are constantly in motion, and they are fast. Stephanie needs to move us quickly, or we'll lose them. But she also wants to maintain some distance, so we don't disturb them. It's a bit of a dance to find that just right spot.
Ooh, I just saw a fin.
Everyone has a job to do. Stephanie's in the captain's chair. Laura will try to get clear photographs of every dolphin we see. Millie will write down notes, and I'll just try to stay out of the way.
We have Zeppelin and Blimey.
Hands on the steering wheel and eyes on the water, Stephanie calls out the name of each dolphin to put into the notes.
ZEP and BLM. Yeah, you got them. They might come again. They're still just beneath the surface. Coming up, maybe. Coming up. Yep.
They're so close.
Stephanie is mindful of keeping some distance, but the dolphins aren't as concerned about the rules. They swim close to the boat, zipping around and seeming to check us out. When they swim over dark patches of seagrass, they can all but disappear, and then all of a sudden they pop up again to grab a quick breath.
Coming up.
Even though I can see them coming, it's delightfully startling every time they crest the surface. These are Indo-Pacific bottlenose dolphins, smaller than some other species, but still big. They average around 2.5 meters long, or more than 8 feet, with a maximum weight of about 230 kilograms, or about 500 pounds. But all that bulk doesn't limit their grace. It's actually hard to call what they do swimming. It looks more like dancing or flying. Their smooth, shiny bodies roll past us in a heartbeat as Laura tries to get a clear portrait of each one.
We try and get Blimey one more time.
As if she heard Laura's request, Blimey pops up and looks right at us, and Laura presses down on the shutter.
Thanks, Blimey. Cool.
With the visuals taken care of, it's time to move on to sound.
So Laura's pulling out her recorder, plugging in the hydrophones.
A hydrophone is just a waterproof microphone attached to a long cable. This team has 4 of them. As Laura gets everything connected and ready to record, Stephanie keeps the boat following the dolphins from a distance. They seem to be on the move towards something. Or someone.
We have another dolphin up ahead. I think it's Juicy. Blimey's in the bow. Hey guys. Both in the bow.
Oh, wow. Right under the surface.
And then they're gone again. It's shocking how quickly a group of 500-pound animals can just disappear. The 4 of us stand in the boat, looking in 4 different directions, waiting, watching. We know they're nearby, but we don't know exactly where or when they might pop back up to take a breath. Stephanie uses the temporary pause in activity to look over Millie's notes and tell her what needs to be added.
So the 5-minute information would be travel. The 2 other animals here.
They're back. Stephanie interrupts herself to call to Laura, telling her that Juicy is not the only dolphin that has joined this group. There's another one, so far unidentified. Then she quickly turns back to Millie.
Travel, regular, straight, slow, tight.
There's a lot happening all at once, with dozens of these kinds of teachable moments every hour. And Stephanie has to find a balance between making sure the data get collected correctly and giving the younger researchers freedom to do things themselves.
So there's just going to be cables running around the back as well.
Okay.
Laura is about to start recording.
Blimey just ahead. Juicy's here.
Yay!
So are there 4 here?
Yes. So that's Juicy. She's got a really gnarly peduncle, like an old shark bite wound, makes it very scarred.
Love Juicy. Juicy's shown up on a few days now, becoming a firm favourite.
How old is she roughly?
Lucy was born in 2001, so she's about 22 years old, and her calf is about 3.5. So she's still quite young, you know.
Yeah, 20-something.
20-something.
Oh, wow. 3 just all came up.
Young dolphins like this calf named Jungle usually stay with their mothers for around 4 years. At first, they depend on mom for milk, but even after they're weaned, they usually stick around, perfecting their hunting skills and learning how to fit into dolphin society. I can't help but notice some parallels between the animals in the water and us humans up in the boat. Altogether, we're a total of 8 mammals working in 2 teams, using acoustic communication to learn from our leaders. And then, for me, came one of the more magical moments of this experience.
We have a speaker,
Yeah.
so we're hearing the hydrophone.
Laura has flipped on a speaker in the boat so we can hear in real time the conversations the dolphins are having in the water around us. Suddenly, we're with them in a completely different way.
I love these guys.
I'd heard recordings of dolphin sounds before this trip, and you probably have too. But this was the moment I learned the enormous difference between hearing a random recording of some anonymous dolphins and being with actual living individual creatures and hearing their voices as they fly through the water all around me.
Juicy is at 230 degrees.
That might be the calf.
That high-pitched swoop is called a whistle, and it's one of the most important sounds in dolphin communication. Laura is overjoyed to hear it because whistles are at the center of her research for this trip. She wants to learn more about how they're used between mothers and calves, like Jungle and Juicy are doing right now.
Juicy at 280 degrees.
With calf
With
BP.
the calf in BP.
BP stands for baby position, meaning right next to mom and moving in tandem with her. It's another quick way of noting how the dolphins are grouped and relating to each other.
So cool, you guys are making me cry.
Oh, amazing. I could cry with joy as well. This is a great recording for me.
I brought my own hydrophone on this trip, and I'm eager to get it in the water. But soon, this group of dolphins disperses, and Laura pulls her gear back up into the boat.
What do you call those kinds of sounds that...
Oh, so they were buzzers. So when they're foraging, it's very rapid rate echolocation. They're basically using it to gain a lot of information on their environment, right, and potentially the prey items that they're tracking. And we've also heard a lot of whistles, which are predominantly social signals as well. So it's likely they're communicating with each other or, you know, potentially the other animals that we've initially saw but are not with us right now.
Uh-huh.
We head off to a new spot across the bay, and as the boat picks up speed, it's harder to talk. So I settle in and watch the waves for a while. This team has been gracious enough to let me tag along for several days, so there'll be time for more of my questions later. And I have a lot of them. I want to know everything about these whistles, what they mean, why they matter. I want to ask Stephanie a lot more about the male alliances that she's studied and how they use sound. But right now, it's time to take a deep breath and appreciate where I am and what I'm getting to witness. I don't have to understand it all to know that I have just been visited by wondrous beings, creatures full of beauty and power and intelligence. And they've survived on this planet for millions of years by listening to each other. We'll have more after this short break. Hey, I want to take a minute to thank you for listening to Threshold and to explain how important you are in getting the show made. Most podcasts raise money by selling advertising, and that pushes them to make a lot of episodes as quickly as possible. But that's just not who we are. Our show is about thinking deeply about how humans are fitting into the rest of the web of life. We take you places and craft stories that are intellectually challenging and emotionally rich. That's the kind of show we want to make, and that's the kind of show you've told us you want to hear. That's why we created an independent nonprofit media company, and why nearly all of our funding comes from listeners like you. This is not the easiest way of funding a show, but it is the way that's most aligned with our mission. And it's worked so far, thanks to people who decide to support it. Our year-end fundraising campaign is happening now through December 31st, and each gift will be matched by our partners at Newsmatch. That means if you can give $25, we'll receive $50. You can make your donation online at thresholdpodcast.org. Just click the donate button and give what you can. And again, thank you so much for listening.
I'm Dallas Taylor, host of 20,000 Hertz, a podcast that reveals the untold stories behind the sounds of our world. We've uncovered the incredible intelligence of talking parrots.
Basically, bird brain was a pejorative term, and here I had this bird that was doing the same types of tasks as the primates.
We've investigated the bonding power of music.
There's an intimacy there in communicating through the medium of music that can be really a powerful force for bringing people together.
We've explored the subtle nuances of the human voice.
We have to remember that humans, over many hundreds of thousands of years of evolution, have become extremely attuned to the sounds of each other's voices.
And we've revealed why a famous composer wrote a piece made entirely of silence.
I think that's a really potentially quite useful and quite profound experience to have.
Subscribe to 20,000 Hertz right here in your podcast player. I'll meet you there.
Welcome back to Threshold. I'm Amy Martin, and for the rest of this episode, we're going to do some time travel. We're going back to a world long before dolphins, before dinosaurs, before they were any animals or plants. If we could transport ourselves back to the very early Earth, we would find a barren world, blanketed in toxic gas. The atmosphere had almost no oxygen in it. There was no life at all. The only thing making sound was the planet itself. Storms, earthquakes, ocean waves, volcanoes. And that's how things were for a really long time. The Earth is around 4.5 billion years old. And for about 90% of those years, nothing existed that was capable of intentionally making a sound or receiving it. So how did we get from that world to this one? How did the Earth transform itself from a place of such unfathomable quiet into a nonstop symphony of sound? We're going to spend the rest of the season telling that story, tracing the sonification of the Earth roughly in the order in which life evolved. It all started with a silence too long for us to truly comprehend, but I wanted to try. And it turns out one of the best places to do that is just down the Western Australian coast, from where I met the dolphin researchers. Okay, I'm just in the parking lot. Pardon me. Just in the parking lot for the Hamlin pool. I leave behind one talkative Australian raven and a small flock of chiming wedgebills and walk the short distance out to the edge of Hamlin Pool, a big bay with a surface smooth as glass. I just want to try to listen here for a little while. The water is so still. There's not a ripple. There's no birds landing on it. There's no bubbles or any sign of movement. It's early and I'm alone, but those aren't the only reasons this place is so silent. Hamelin Pool has an inner stillness. It's extremely salty, twice as salty as the open ocean, which means it's hard for plants and animals to survive here. And against this canvas of quiet, every sound made by a living thing pops out. A bird peep, a fly buzz. For most of our planet's history, this kind of silence reigned supreme. Just think about the entire Earth being that quiet. There was nothing breathing, flying, walking, crawling. A whole planet with nothing that had a voice. But although Hamelin Pool may be a profoundly quiet place, it isn't actually as lifeless as it seems. There's a lot of mysterious blackish gunk carpeting the beach in front of me, almost like a bathtub ring of slime growing where the water meets the shore. And these are communities of microbes. They go by sexy names like gelatinous microbial mats or pustular sheets. And they built a bridge between the barren early Earth and the lush, loud, fruitful world we enjoy today. Ancient microbes were the inventors of what is arguably the most important technology of all time: photosynthesis. A couple of billion years ago, they started to tap into the sun's energy and produce oxygen. And that changed everything. Bit by bit, they pumped that oxygen into the sea.
And after a while, then all that oxygen created by photosynthesis from microbes eventually saturates the ocean. The ocean can't hold anymore. Where does the oxygen go? It goes into the atmosphere.
This is Dr. Erica Sosari.
The atmosphere becomes oxygenated, which essentially that allows for evolution, which then here we go, and finally get to us.
The slimy mats I saw growing in Hamelin Pool were microbes, still performing these ancient rituals, doing the work that led to all other life on Earth. They don't look like much at all, but they hold the origin story of every call, cry, squawk, or song ever heard.
This is a living system, still doing this, still doing these same processes that were happening billions of years ago. There is no place else on the planet that represents that in its entirety. It is really this window into the ancient.
I'm curious about you. Like, what stage in your development did you realize, I really want to learn a whole lot more about goo?
I guess technically I'm a marine geologist. I'm a carbonate sedimentologist, but I look at marine rocks.
Erica is based at the Smithsonian Institution's National Museum of Natural History in Washington, D.C. She first visited Hamelin Pool while working on her PhD, and she was so blown away by the glimpse it provided into the early Earth that she moved to Western Australia and lived close by for several years, just so she could continue studying the place.
So I have sort of this obsession with time. I've always had this obsession with time and kind of infinity and what it means and the big picture and how significant our lives are and what we do because the time is so big. And it's like, kind of figuring out the puzzle of what life means on huge scales.
And key pieces of that puzzle can be found in these communities of microbes at Hamelin. Erica is one of the world's leading experts on them and the stony structures they create, which are called
microbialites, which are basically rocks created by microbes.
We don't tend to think of microbes as creating anything, except infections maybe. But at some point, way back in time, they started to make rocks. Clotted thrombolites, branched dendrolites, and layered stromatolites. The world's oldest fossilized stromatolites, found in Western Australia, are almost 3.5 billion years old. And the microbes at Hamlin Pool are still making these rocks today. It's the largest known collection of living marine stromatolites in the world.
What Hamlin represents is I don't even have a word for what Hamlin represents. It's a really spectacular place. It's a living laboratory.
The stromatolites are kind of like the Machu Picchu or Egyptian pyramids of the microbial world. These are structures made by communities of living things with a story to tell. They grow close to the edges of Hamlin Pool in the shallow water, maybe a foot or two high. Some of them look a little bit like toadstools. Others resemble stubby fingers or brainy mounds. But whatever form they take, there's something about them that signals life. You can see familiar organic patterns in them. You can sense that they grew. And this is how it all began. Even though the microbes themselves are very quiet, without them, there would be no voices to speak or ears to listen. Erica says one of the essential ingredients in this process is a coating the microbes make and cover themselves with.
It's called EPS. It's exopolymeric substance.
Exopolymeric substance. I asked her to translate that into non-sciencey language.
It's like it's the slime of life. You know, it's a goo.
It's a goo. We've got a microbe that makes a goo.
Yeah.
As sediment in the water floats by, some of it sticks to this goo, kind of like dust sticking to flypaper. It builds up layer after layer into stone.
And you build up kind of this laminated structure. So that's a stromatolite.
The EPS can actually do all kinds of cool stuff. It helps the microbes communicate with each other. It acts as a sunscreen. It even changes the chemistry of the water, which helps in the stromatolite building process. So it's a self-produced goo that does chemistry.
Yes, or has chemistry happening. Yeah, all around it.
Okay. There's like a lot going on.
Oh, yeah, there's a lot going on.
I like to think of these microbial communities as the world's first cities, with the bacteria in them bustling around, working as architects and engineers, carpenters and chemists. They farmed sunlight and produced oxygen, the oxygen that led to me talking to you right now.
These lineages of bacteria, life persisting for billions of years.
While everything changed around them, again and again and again, these microbes carried life forward, passing it on and on and on, one generation after another.
It's not a timeline that I still think I can wrap my mind around, but I find it sort of comforting that there is this long stretch of time that these rocks represent, and I am drawn to that.
What do you think the world sounded like when the only living things were these microbes?
Crashing waves. I don't know, a lot of water. Mm-hmm. But underwater, there's something about silence. I can't imagine. I mean, silence. What does that sound like for oxygen bubbles to rise to the surface, crashing waves? Kind of meditative and calm, which is crazy because it's a time in Earth's history where it's very chaotic and yet, you know, there's like the kind of the peace that life brings.
As I stood on the beach at Hamlin Pool, I tried to imagine more than 3 billion years of that silence. Eons of ear-splitting emptiness. And then, finally, the planet began to sing. Every song or call or cry made on Earth happened in just the last 1/10 of the planet's existence. The cacophony of life that we take for granted is actually exceptional. Silence is the norm on our planet, or any planet that we know of. Erica's work is being used in the search for life on Mars. And maybe someday we'll receive communication from some extraterrestrial being. But so far, we Earthlings are singing together into the void. The only voices we've ever heard are each other's. This episode of Threshold was written, reported, and produced by me, Amy Martin, with help from Erica Janik and Sam Moore. Music by Todd Sikafus. Post-production by Alan Douches. Fact-checking by Sam Moore. Special thanks to Tim Lammett and Miles Parsons. This show is made by Oracle Productions, a nonprofit organization powered by listener donations. Deneen Weisky is our executive director. You can find out more about our show at thresholdpodcast.org.